Okay, so I'm going to talk about the last one. Back to the two-dimensional problem. Because many times two-dimensional problems are more interesting because we can ask more. Okay, so now we have this a boat, right? Okay, let's say we have a big boat here, and then there's 4 small boats. They call the tugboats. 4 tugboats are used to bring a big ocean liner. Okay, that's so big, it's not easy for the south to move to a harbor, so that's why they want to use a small boat to move this big liner to this pier. Each tugboat exert, because there's the engine inside boat, right? Exert a 5,000 pound force. Okay, so each small boat can give a power of 5,000 pound force in the direction shown in this picture. For example, so this is one boat in this direction. Now we give you the angle. And this is another boat showing in this direction. And this is a third boat going in this direction. And then this fourth will go in this direction. Because normally that's the engine is inside, so that they provide a force on this rigid body or on the big liner. Okay, so 4 boats are used to bring this ocean liner into a certain location, and each small boat exerts 5,000 pounds in the direction shown below. Now, number 1, we need to determine the equivalent force coupled system at the 4 mass O. That's this point. Okay, this probably is some given point. Oh, that's fine. That's the first question. And that's very easy, right? Because as long as we determine a point, then we can just move those forces to that point, and correspondingly we can calculate the moment. Okay, that's the first question. Actually, the second question is more interesting, which we're going to do both later on. So, second question: can we find a point? Okay, can we find a point on the hull of this big liner, outside this boundary? Just one point, or in other words, one boat, where a single but more powerful tugboat, assuming each small boat has the maximum force capacity like 5,000. But let's assume we have another small boat. However, that small boat is more powerful. Okay, but instead of using four small boats, can we just use one, but more powerful tugboat, which can push to produce the same effect as those original 4 tugboats? In other words, use those 4 tugboats to move this to certain location. Okay, just in case this big liner, for whatever reason, lose power or whatever, right? Okay, so we are using 4. But now, instead of using those 4, can you use 1? But that one, you need to determine, or in other words, we need to calculate where we need to put that same small boat, but it's more powerful. And then we also need to calculate how powerful it is. It's going to be probably more than 5,000. Okay, we'll see. Okay, so let's do this one step by step, right? Number 1, first question, okay? We need to calculate the equivalent force coupled system at point O, okay? With those 4 forces acting on. This is really body. We have 4 forces, right? Let's do the first question. The first question, force coupled system at point O, which is here. So typically, you better have the coordinate system. Let's say this is point O. Let's say this is x direction, and then maybe this y direction. It doesn't matter. This is the original picture. I just copy again from here because we know all the different angles, directions. Now, we have 4 forces acting on here, 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 and here, right? So then we just need to determine those forces. And then we just need to add them together. That's called the resultant force at point O. So the resultant force at point O is simply the summation of all 4 forces. Let's do one by one. First force. Let's call this the first force due to boat number 1. So first force, where's magnitude? Magnitude given from the beginning. It's at 5,000. Every boat has the same magnitude, 5,000 pounds. So 5,000 pounds, you need to split 5,000 pounds in this direction into x and y components. So x and y components, if we were given with an angle, so this one times cosine of this angle, that gave you the x component. Okay? So the x component is 5,000 times cosine 60. But it's going to that direction, by the way, okay? Because when you use a tugboat, you need to have the bolts giving the force into this reed body. Otherwise, it's leaving this that line. It doesn't work. So that's going to be this force. So that the x component must be positive. So 5,000 times cosine 60, that should be 2.5. Check it out. Okay, 2.5. So 2.5 is the x component of this force. Similarly, with the y component of this force, this is wait. Let me see. There's that shouldn't be the. This is 600, right?
They use kilograms.
Wait. It's 5,000 pounds. 5,000 pounds. That's obviously this is 5,000 pounds. Then this one should be 2.5. It is 2.5, right? Oh yeah, I'm sorry. Right. Okay, they use kips. Right. So you have a 5,000 pounds. You can use pounds as a basic unit, or you can use 5 kips. You know, 1 kip equal to 1,000 pounds. I believe now they're using kips. This is called the KIP. Right? Anyway, so they use 1,000 pounds as basic unit, which is called the kip. So then 5 times cosine 60, that's 2.5. That's right. And then 5 times sine 60, that's finally end up with 4.33. But keep in mind, this y direction is an opposite direction. That's why you put a negative sign in the front. Okay? So that's the first force due to both 1. Any questions? Second force. This one. So this one, they didn't give you angle, but they're basically telling you, okay, this if you split, that's a 3/4. That means this is 5, right? So that's in the split into 3/5 and 4/5. So when you have a 5 kip force acting on this point, then the x components, that's going to be 3/5 times 5. That's 3. Okay, that is 3. Okay, so this x component is a 3. And the y component, that's a 4/5 times 5. That's going to be 4. But it's negative because it's going down as well. So that's a 3 minus 4. Okay, they need to write the unit. You finally need to write the unit. Okay, so that's going to be KIP. Okay, so that's the second force. Third, this is a force acting on this point, serving as the third force. This is going in the vertical direction, 5,000, or say 5 kip. So that is going to be negative 5 J. There's no x component, right? This one. And finally, this force, or say this force, you have a 45 degree. 45 degree to 5,000 or 5 kip. So going to have both same magnitude in x and y. You just need to have 5 times cosine 45 or 5 times sine 45. Either way, they give you 3.54 in both x and y directions. You simply add all these forces together to get the resulting force. Okay, that's the first part. Calculating the equivalent force coupled system at point O with respect to the resultant force, which is here. Any questions? Okay. Now, second, we need to calculate the resultant moment at point O. And by the way, when we're talking about the resultant force at point O, but in reality the result is independent from that point. Okay, we need to use any information related to the distance, like 90 feet or 100 feet, whatever, right? 50 feet, we can use that. So in other words, this is independent from the point. However, the resultant moment is to be summation of R cross F. So we got F1, F2, F3, F4, but now we need to calculate or characterize the 4 R's, R1, R2, R3, R4, right? Let's do one by one. First of all, what is R1 cross F1? We got F1 here, which is here. What is R1? Again, R1 is the distance vector from the point you want to calculate that resultant moment, right? To the point, the force applied on this one. So this is R1 from O to this point. From O to this point. So in other words, you just use this point, subtract O. If we set up the coordinate system with the origin point at O, that means the two component O are 0, 0. So in other words, just this point subtract 0, then this point itself. So this point, what are the two components at this point? So x component is this one, which is negative 90i, so negative 90i. And then y component is 50 going up, and positive 50j. So this is R1. Okay, very easily using this point, subtract this, but this 0 itself, don't worry about this one. Just this component itself. So because this is the original point. You move to the left, that's negative. Correct? Yeah, that's fine. You can also use that way. So this is, let's call this point 1, right? Point 1, you have a, what is x component point 1? That's still negative. Right? Negative 90 and then positive 50. That's this point. And then subtract 0, 0. Okay? So this is the first R1. And then cross F1, which is this, plus R2 cross F2. F2 is this one. What is R2? R2 is from point 0 to point 2. So this time, this one, use this, subtract this. The two components of this one is 150. That's why I have 100. That's a mistake. I'm sorry, it's a 70, okay? Because it's kind of going down like this way. So this point and this point are at a different level. So this is in fact 70, okay? So 170. So 100I, 70J. And then cross F2. Questions? Okay, number 3, R3 cross F3. R3 is from point 0 to this point. Okay, point 0 to this point. So then it's going to have 100 plus 200 plus 100, 400. Yes, 400, right? So that's x components, and then y component still 70. So 400 plus 70. And then cross F3. F3 is here. So that's why we just write this again. Finally, F4. F4 is acting on point 4. So R4 correspondingly would be from 0 to point 4. 0 to point 4. So then x component is 100 plus 200 is 300. But y component is going down with, you didn't tell us this one. I guess the same thing. It's symmetric, right? So that's negative 70. Yeah. Okay. So from here to here, that's 100, 200, total 300. This one is going down. And this is the same. So that's negative 70. So this is R4 cross F4. F4 is here. And then you simply do the math, right? So basically Ri cross I equal to 0, 0, I cross j equal to k, whatever, you finally end up with this number. So it's going to be negative 1035 k. In other words, the resultant moment is 1035 in terms of the magnitude. They forgot to writing the unit, okay? So you need to know how to write unit. What's the unit of this one? Kip, start, food, right? Yes, feet. Okay, so kip, start, feet. And this negative sign indicates clockwise. Okay, so magnitude, even though you finally end up with this answer, right? So this negative sign doesn't mean it has nothing to do with the magnitude. Magnitude from physics is always positive. This is basically to indicate the direction. Okay, negative k. Negative k means clockwise. Okay, so that's the first part. In other words, this one is equivalent. Let me see if I have that figure. Yes, okay. So this one having 4 forces acting on the different locations, this one is equivalent to the same rigid body with 1 force acting on point 0 and 1 moment at point 0, which is this. Okay, so finally we got the rigid body here. At this point 0, we have a resultant force having 2 components, 9.04 and the negative 9.79. So in other words, you have x component of the resultant force, 9.04 in this direction. The y component is 9.79 in the opposite j direction. That's why I have negative sign here. So this is called the resultant force, or in other words, you can plot this if you want. Okay, with a certain angle, you can easily determine based on these two components. In addition, there is a resultant moment, which is negative 1035. So 1035 means clockwise. That's why you have a clockwise resultant moment. So this is the solution for the first question. And let's go back to look at the first question. Question A, we can determine the equivalent force coupled system at point 0, and with those 2 resultant force and the resultant moment. Any questions? Okay, equivalent. Now let's move to the second question. The second question is, can we find a point on the hull, that means on the boundary, on the surface, where a single, but it can be more powerful, small boat should push to produce the same effect. Okay, so this one, I'm gonna use the overhead projector because I have this picture as well. Let me show you how we can find that point. Okay, so this one is done. Now we move to this one. However, I want to say this is equivalent to this rigid body at point O with the resultant force with this is the x component, y component. In other words, this one is called R. And also you have clockwise resultant moment, which is a 1025, right? Okay. We need to determine which point on the surface. Okay. You have this surface, you have this surface, or you have this surface, right? These two. Of course, you can consider one by one. Okay. Let's say it's going to be somewhere here. It's going to be somewhere here. We just need to determine where this one is, or what's the location. If that's the case, this is the original point, right? So we have this called x, and this we call y. Okay? So at this point, actually, no matter what, from here to here, just like this, it's all 70. So then, this is 70, which is fixed. But we just need to determine this one. And you gave a symbol called x. And our job is to determine this x. Okay? So in other words, we want to move this force from point O to this point. Then, how are we going to do that? Well, same thing. We basically create two virtual forces. Let's say this is the force direction, right? I'm going to create two virtual forces at this point. And then this is the R, and this is R, this is negative R. Okay? So, this R and this R form a couple. So I'm hoping this newly formed couple will cancel with this existing moment. So if this newly created couple, additional, happen to cancel this one, then what? There's no moment. And that's exactly what we want. So from that equation, we can determine x. Okay? So this is the idea we want to do. Then let's just do it in terms of mathematics. What is the additional moment due to the couple? That's going to be what? That's going to be R cross R. Okay? So you can have this positive R, negative R, depending on which R you want to pick. You want to pick this one, or you want to pick this one. It's up to you. Okay? Let's say we pick this one, this R. Okay? And we know this R, which is, let me write down this R. (9.04I) negative 9.79J. Okay, so this is R. If you go back to look at the solution from step number 1. If this is R with this force, then this distance vector must be from here to here this time. Okay? From here to here. Which means from this point you create it to this point O. So that's going to be O, let me write here, O minus, that's point H, for example. And then let's do one more step. What is point O, the two components? That's 0, 0 minus point H. What is point H? Point H, the x component is x. What is the y component? 70 cross this force. So then what we got is a negative x, right? 0 minus x is negative xi. 0 minus the negative 70j. So this is a distance vector called r, and then cross. 9.04I minus 7.79J. So this is what you can continue to calculate, but this is the additional moment created by this couple, or by these two forces. And I want this one to be canceled with this existing one. So how I'm going to do that? Well, we add them together, and this set equals 0. So this additional moment, so R cross this plus, that's resultant moment at point O, need to be equal to 0. So now let's do the math. R cross R is here. So negative xi plus, negative 7j cross 9.04I minus 7.79j. I don't think this is 7, this is supposed to be 9, right? If I remember correctly. Yeah, I'm sorry, this is 9.79. It's here, it is 9.79. For some reason I later write 7.79. Okay? And then plus this one. This is the resultant moment we calculated from previous step. That is negative 1035. Okay. If you go back to look at the resultant moment answer from step 1, that's this one. And that's equal to 0. Okay, so let's continue with this equation. We just do one by one. So I cross I equal to 0, don't worry. I cross j equal to k. So minus x times minus 9.79, I cross j equal to k. So this is the term we need to keep. And then j cross I. So that means plus negative 70 times 9.04. So this one times this one. And j cross I. What is j cross I? The negative k. Okay? And then j cross j equals 0. Okay? And then plus negative 1035k. And that's equals 0. So anything in front of k combined, that's going to be negative positive 9.79x. This one is positive 70 times 9.04. And then negative 1035. And the times k equals 0. So then this one must equal 0, right? So then from this equation, you get x. Okay, before I write x. Any question? Yes. I'll answer the next question. Yes. First, we need to determine the location, and then we're going to do that. Okay, so let me switch back to this one. I'll give you x first, and then I'm going to answer your question. Okay? So finally, I'm sorry, here. So finally, this one. So finally, let's randomly assume a point, which this is the x. They do use x, right? So from this equation, they use a different way. No matter what, x finally equals to 41.1. 41.1. So that's the location. That means at this point, x is 41.1 and y is 70. But the second question is more powerful. How powerful? That is this r, because this is never changed r. When I move this one here, it still has the same r. So how powerful this r? That's going to be square root of 9.04 squared plus 9.79 squared, and that's square root. And that's a number. So it's going to be around like 10 again, right? So that's why it's more powerful. Originally, you only require 5,000 for each bolt. But this time, if you want to use one bolt, it's going to be more powerful. That's